On Thursday, in a village called Dolné Plachtince in southern Slovakia, the temperature reached 42.2 degrees Celsius, 108 Fahrenheit. It is a national record. The day before, Austria set its own, 41.2 at Bad Deutsch-Altenburg, which itself broke a 41.0 recorded in Vienna the day before that. Italy has all 27 of its major cities under the highest level of heat alert. And on the Danube, Europe's second longest river, the water has dropped so low that Slovakia's only nuclear power station is running at 80% of capacity. Not because anything failed, because there is not enough river left to cool it properly. That is this week, not June, not the July peak, this week as I record. So the claim in the title of this video is that the worst is still ahead. And I want to tell you now that I think that is true. I also think almost everyone saying it means the wrong thing by it. Because there is a version of the worst is still ahead that means next week will be hotter. That may or may not happen. Forecasters currently expect this dome to hold into mid-August, and beyond that, nobody can tell you honestly. And there is a second version, which is the one I want to spend this video on. It has nothing to do with the temperature at all. It is already locked in regardless of what the forecast does, and it will still be unfolding in November. So the question is, ahead in what sense? I will answer it properly, which means going through the mechanism first, why this high-pressure system will not move, then what it has already done to the ground underneath it. No guessing. No dramatizing, just the numbers, the mechanism, and the stakes. Before we start, if you are in Europe right now, tell me in the comments where you are and what the nighttime temperature has been, because the nights are the part nobody outside the affected countries understands. Subscribe if you want the plain version of these, and a thumbs up helps. Let us go for 5,000. Now, let us get into it. Start with why this will not move on. Weather at these latitudes normally travels west to east, carried by the jet stream, a fast, narrow river of wind high in the atmosphere, driven by the temperature contrast between the pole and the tropics. Systems queue up and pass through. That is why a typical European summer gives you a hot spell, then a change, then another. But the jet stream does not run in a straight line. It meanders in enormous north-south waves called Rossby waves. And under certain conditions, those meanders stop progressing eastward and simply lock in place. The configuration over Europe right now is a textbook omega block. It is named for the Greek letter because that is the shape the jet stream traces. A large ridge of high pressure in the middle with a deep low pressure system on each flank, one over the North Atlantic, one over Russia. Omega. The two lows act like doorstops. The high in the middle cannot advance east because there is a low sitting in the way, and the jet stream splits and runs around it rather than through it. The whole arrangement can persist for 1 week, 2 weeks, sometimes longer. So the pattern that would normally deliver relief is the thing that has been switched off. Now, what does the high itself actually do? High pressure means air is sinking. And sinking air warms, not because it gains heat from anywhere, but because it is being compressed as it descends into denser air below. This is called adiabatic heating, and it is the same effect that makes a bicycle pump warm in your hand. No energy added, just volume reduced. Sinking air also suppresses cloud formation, because clouds form when air rises and cools to its dew point. Under a dome, air is doing the opposite. So you get clear skies, which means the full solar load hits the ground every single day, unfiltered. And on top of that, this particular dome has been drawing air northward off the Sahara. Then comes the part that makes it self-reinforcing. And this is the piece that turns a hot spell into an event. When soil has moisture in it, a large share of the sun's energy goes into evaporating that water rather than raising the temperature. Evaporation is a heat sink. It is why you feel cold stepping out of a shower. Meteorologists call this the latent heat flux. Dry the soil out, and that sink disappears. Now, the same sunlight goes almost entirely into heating the ground and the air above it. So, the dome causes drought, and the drought makes the dome hotter. Each day of clear sky removes more moisture, and each unit of moisture removed makes the following day hotter still. The system winds itself up. That is why these events do not plateau. They escalate. Let me put numbers on what that has produced this year, and I want to attribute each one. According to the Copernicus Climate Change Service, June 2026 was the second warmest June globally in the Era 5 record. A global average surface air temperature of 16.54 degrees, 0.56 above the 1991 to 2020 average. But the European figure is the one that matters here. Western Europe had its warmest June on record, an average of 20.74 degrees, which is 3.05 above the 1991 to 2020 baseline for the month. France recorded its hottest day ever on the 24th of June, a national average temperature of 30.0 degrees, according to Météo France, beating the record set the previous day and surpassing the previous marks from July 2019 and August 2003. A top-level red alert went out for 58 departments, a record covering most of the country. And France also set a national record for an overnight temperature, 22 degrees. That last number looks like the least dramatic on the list. It is the most important one, and here is why. Your body sheds heat by radiating it to the surroundings and by evaporating sweat. Both work best when the air is cooler than you are. Skin sits around 33 degrees, and core body temperature must hold near 37. During a hot day, you accumulate heat faster than you can shed it, and you run a deficit. A normal night pays it back. The ground radiates its stored heat to space. The air cools to 15 or 16, and you unload. Your cardiovascular system, which has been working hard all day pushing blood to the skin to dump heat, gets to stand down. Take that away. Hold the night at 26 or 27, and there is no repayment. The deficit carries into the next day, and the day after, and it compounds. This is why heat mortality is not driven by the peak temperature. It is driven by duration. A single 40-degree afternoon is survivable for almost everyone. 40 degrees for 3 weeks, with nights that never drop below 26, is what fills mortuaries, through cardiovascular failure, kidney failure, and the tipping of existing conditions into crisis, most of it happening in people's own homes rather than in hospitals. And the deaths are counted afterwards, statistically, as excess mortality, the number of people who died above what the models predicted for that period, which is why the figure always arrives weeks late, and why it is never on the news the day it happens. For scale on what that eventually adds up to, research published in Nature Medicine found that the 2024 European heat season was associated with more than 62,000 heat-related deaths across the continent. That is the size of the thing being measured, and it is measured almost entirely in arrears. 2 more pieces of physiology because they explain who dies and where. The first is wet bulb temperature, and it is the number that actually governs whether a human can survive outdoors. Take a thermometer, wrap the bulb in a wet cloth, blow air across it. The reading you get is the lowest temperature that evaporation can achieve in that air. If the air is dry, evaporation is efficient, and the wet bulb reading falls well below the air temperature. If the air is already saturated, evaporation does nothing, and the two converge. That matters because sweating is evaporative cooling. Once wet bulb temperature approaches body temperature, sweat stops working. Not because you are not producing it, but because it will not evaporate. There is no behavioral workaround. Shade does not help, fans do not help. And this is why European heat, which is typically dry, produces 42 degrees in Slovakia that people survive, while considerably lower air temperatures in humid climates can be lethal. The dry Saharan air feeding this dome is, in that one narrow respect, working in Europe's favor. The second is the urban heat island. Asphalt, concrete, and brick have high thermal mass. They absorb solar energy all day and release it slowly through the night. Add the loss of vegetation, which would otherwise be evaporating and cooling, plus waste heat from vehicles and air conditioning, and a city center can run several degrees warmer than the countryside around it. The gap is usually widest not at midday, but overnight, exactly when the body needs the recovery. Which is why heat mortality concentrates in cities, and within cities, in dense districts with little green space and older housing stock. The hazard is meteorological. The distribution of it is architectural. Now the fires, because they follow directly from the soil moisture story. With one twist, most coverage has missed. Europe went into this summer after an abnormally wet winter. Long-lasting rain, frequent storms. And that produced an unusually good growing season. More grass, more brush, more undergrowth than normal. Then the heat arrived and cured all of it. That is the sequence that produces the worst fire years. Not drought alone. Drought alone limits how much fuel grows in the first place. A wet season that grows a heavy fuel load, followed by a hot, dry season that desiccates it, gives you the maximum quantity of the most flammable possible material. The results, as of the 4th of August, at least 17 civilians, 6 firefighters, and 2 helicopter crew killed. Roughly 330,000 people forced from their homes in Spain and France alone. At the end of July, fires crossed the Portugal-Spain border around Valpaços and Pinzio in Portugal and Fermozelle in the Spanish province of Zamora, with around 800 people evacuated from 14 localities. Copernicus Sentinel-2 imaged the burn scars from orbit. Across central Spain in late July, Celas in Guadalajara, about 1,700 hectares and 6 municipalities evacuated. Brieva in Segovia, over 3,000 hectares. Heatwave in Teruel, around 1,400. Almorox in Toledo. Burgojondo in Avila. The EU's RescEU fleet currently has 22 firefighting aircraft and 5 helicopters on standby across 12 countries, with 777 pre-positioned firefighters. That is the largest deployment since the program began. Now the rivers, and this is where it stops being about air. Between the 1st and 3rd of August, Copernicus Sentinel-2 satellites recorded exceptionally low water on 4 of Europe's largest rivers simultaneously. The Loire near Saumur in France, the Po near Cremona in Italy, the Rhine near Beauport in Germany, and the Danube near Pax in Hungary. 4 of the continent's main arteries in 4 different countries drawn down at the same time. And that is not an aesthetic problem. The Rhine is one of the busiest freight waterways in the world, and barges have to carry less cargo as the draft falls. Thermal and nuclear power stations draw river water for cooling, which is why the Slovak plant is throttled back to 80%. Low flow also means less water to dilute whatever is discharged into it, and warmer water holds less dissolved oxygen, which is what kills fish in these conditions. In the Italian Alps, the Adamello, the largest glacier in the range, went into this summer after a winter that brought very little snow. That fresh snow layer normally acts as a reflective shield through early summer. Without it, the ice surface was exposed to direct solar radiation weeks earlier than usual and has been losing mass the entire time. Right, before the answer, one thing to clear up, because it comes up every time. This is not the planet breaking, and it is not a mystery. It is a specific, identifiable, well-understood atmospheric configuration. A block jet stream with a ridge locked between two lows, sitting over a continent whose soils were already dry. Every step in that chain is textbook meteorology. What the research says about the trend is a separate question, and worth stating carefully rather than dramatically. A 2025 study in the Proceedings of the National Academy of Sciences found that the atmospheric patterns which lock extreme weather in place have increased substantially in frequency. That is a finding about how often the block forms. It is not a claim about any single week's weather, and I am not going to make one. I will also say plainly that I am a geophysicist, not a climate scientist. Attribution, working out how much a specific event was made more likely or more intense by a warming atmosphere, is a genuine discipline with its own methods, and it is not mine. What I can tell you about is what heat does to rock, soil, and water once it gets into them, which is the rest of this video. So, is the worst still ahead? Yes, and it is not heat. Here is the thing that almost every version of this story gets wrong. It treats the heat dome as the event and the end of the heat dome as the end of the event. Relief arrives, the temperature drops, the story closes. But look at what is actually now in place across southern and western Europe, none of which reverses when the temperature does. The soil is desiccated to depth, not dry at the surface, dry through the profile, which takes months of ordinary rainfall to rebuild, not one wet week. 4 major rivers are at exceptional lows, which means groundwater and reservoir storage have been drawn down to hold them up at all. A glacier has lost a season of mass it will not get back. And there are now burn scars across northern Portugal, western and central Spain, and southwest France. Hillsides stripped of the vegetation and root structure that held their soil in place. Now consider what happens to that ground when the autumn rain arrives, because it will. Burned soil does not absorb water the way unburned soil does. Fire vaporizes waxy organic compounds in the vegetation, and because soil conducts heat poorly, those vapors drift down a few centimeters into cooler ground and condense there, leaving a buried layer that actively repels water. Add the loss of the canopy and the litter layer, and rain that used to soak in now runs across the surface instead. The hillside stops being a sponge and becomes a roof. And the runoff picks up ash and loose soil as it goes, gets denser, and past a certain point stops behaving like muddy water and starts behaving like wet concrete moving downhill. That is a debris flow, and it carries boulders and trees and arrives as a front rather than as a rising level. The rainfall needed to start one is far less than people assume. In burned terrain, the intensity thresholds used for hazard modeling are on the order of a few millimeters in 15 minutes. An ordinary autumn thunderstorm cell, not an exceptional storm. So, the fires get contained, the dome breaks, the temperature falls, the coverage ends. And the ground above a few hundred European villages stays loaded for the next several years, waiting for a wet afternoon. That is what is still ahead. Not a hotter Tuesday, a hydrological and geomorphic bill that has already been run up and cannot now be unrun, and that comes due in October and November and in the 2 or 3 autumns after that. The atmosphere is the trigger. The ground is the story. It always is. So, practically, while this is still going on, treat the nights as the hazard. If you can get your bedroom below about 24 degrees for even part of the night, that matters more to your physiology than anything you do at 2 in the afternoon. Shutters and curtains closed all day on the sun-facing side. Windows open only once the outside air is genuinely cooler than inside. And check rather than assuming, because opening windows into hotter air makes it worse. Check on people who live alone, particularly older neighbors. Heat deaths overwhelmingly happen indoors, quietly, over days. A knock on a door is the single highest value thing in this entire video. Use the cooling centers if your building has no air conditioning. Libraries, community centers, public buildings. A few hours in a cool space genuinely resets the accumulated load. And if you live below a burn scar in Galicia, Zamora, Trás-os-Montes, Gironde, anywhere that burned this summer, the thing to watch this autumn is not rainfall totals, but rainfall intensity. A forecast of 10 millimeters tells you nothing. Whether it arrives over 6 hours or 15 minutes is the whole question. And if you are told to move during heavy rain, the reason you are told early is that nobody can tell you late. Europe has had hot summers before. What is different about this one is not any single temperature reading. It is that a blocked jet stream held the same configuration in place long enough for the heat to work its way from the air into the soil, into the rivers, into the ice, and into the hillsides. Air recovers in a day. None of the rest of it does. Tell me in the comments where you are and what the nights have been like. Subscribe if you want the follow-up when the autumn rain arrives, because that is the one I will be watching. And thank you for giving me this much of your afternoon. I will see you next time.